This video is brought to you by mywayteaching.com.
So let us try to understand what rotation is and what characterizes rotation. Okay. See, you may notice that in rotation of a rigid body about a fixed axis means that ceiling fan as well as pottery's wheel, every particle of the body moves in a circle, isn't it? Which lies in a plane perpendicular to the axis and has its center on the axis, isn't it? Every particle, it moves in the rotation, isn't it? And it is perpendicular to that center of axis. If this is the axis, this will move in a circle. So both are perpendicular to each other, and it has its center on the axis. That rotation, it is having its center on this axis, isn't it? So you in here you can see in this figure, it shows the rotational motion of a rigid body about a fixed axis. Okay, the z axis of the frame of reference. This z axis is the frame of reference. So it is a example of rotation of a rotational motion of a rigid body. See, here they have considered the particles p1 as well as p2. Okay, both are at different radiuses. Here it is at a distance of r1, whereas p2 is at a distance of r2. So both are having their centers on the axis of rotation, isn't it? c1 and c2 lie in the same straight line, isn't it? And they move in a circular path which is perpendicular to this axis of rotation, that is the axis z. Okay, so here we can see this figure, we can say it is a rigid body rotation about the z-axis. Each point of the body, such as P1 or P2, describes a circle with its center C1 or C2 on the axis. The radius of the circle, that is R1 or R2, is perpendicular distance of the point P1 or P2 from the axis. A point on the axis like P3, it remains stationary. So I told you that, isn't it? It is lying in a plane. So you can see in this figure, the point P1 is a particle of the rigid body. You can see that particle point P1 here, and it is a particle of the rigid body, and it is we have chosen randomly. It is at a distance r1 from the center c1, isn't it? And the particle p1 describes a circle of radius r1 with its center c1 on the fixed axis. The circle lies in a plane which is perpendicular to the axis z, isn't it? This circle, it lies in a plane, and that plane is perpendicular to the axis z. So it also shows another point P2. You can see that, which is at a distance of R2 from the center C2. It also describes a circle which is perpendicular to the axis Z, isn't it? Yes. Okay. And the circles which are described by P1 and P2 may lie in different planes. Both these planes, however, are perpendicular to the fixed axis. For any particle on the axis like P3, you can consider here, here P3 we have considered, for which r is 0. There is no radius, the distance is 0. Any such particle remains stationary while the body rotates. If this P3, it remains constant, right? Even though body rotates, P3 is constant there. This is expected since the axis is fixed and the point is lying on that particular axis. Okay. In some other examples, here we have taken the examples in which axes are fixed. We can see some examples where axis may not be fixed. For a very good example for that is a top spinning in a place. You can see that in a figure. I'll show you that. See, a spinning top. The point of contact of the top with the ground here is O, right? It's tip O and it is fixed. But the axis is not fixed. It continuously rotates, but that axis is not fixed here, isn't it? We assume that the top does not slip from the place to place and so does not have translational motion. Okay. So we know from experience that the axis of such a spinning top moves around the vertical through its point of contact with the ground. We have seen this one sweeping out a cone as you can see here. It continuously moves on the ground with the only the point O is fixed here to the ground. But this axis it will continuously change as it rotates in the on the ground. So this movement of the axis of the top around the vertical is termed precession. Okay, we call that as precession. So the point of contact of the top with the ground is fixed. That is for sure. The axis of rotation of the top at any instant passes through the point of contact. The axis it all the axes it moves through or it touches this point of contact because this O is constant here. Okay, this is one example where the axis is not fixed. Another simple example we can give, it's a kind of rotation in the that is the oscillating table fan. Here it is an oscillating table fan. The pivot of the fan, that is point O, is fixed here. You have seen this also, right? But this fan it continuously moves, okay, from direction. It continuously moves from one end to the other end, okay, so that it can spread the air in all the direction, isn't it? So the axis of rotation of the top at any instant passes through that point of contact. Oh, here also the same thing. So you may have observed that the axis of rotation of such a fan has an oscillating or the sidewise movement in a horizontal plane about the vertical through the point at which the axis is pivoted, that is at point O. We have seen these kind of fans in our day-to-day life, isn't it? Yes. While the fan rotates and its axis moves sidewise, but that point O is fixed. As I told you, it moves continuously. This fan moves and its axis keeps on changing as it moves, but this point O it will not change, it is fixed. Thus it is in more general cases of rotation such as the rotation of the top or a pedestal fan, one point, not one line of the rigid body is fixed. In general case, axis is not fixed, whereas only a single point, as you can see in this particular case the point O is fixed. Through it always passes through the fixed point. Okay, so here we'll deal with very simple cases. Okay, in the next examples you can see here motion of a rigid body which is pure translational. That is the first figure. So this is one example and you can see one more here. Here it is you can see in this figure the motion of a rigid body which is a combination of translational as well as translation and rotation. In the first example, these two figures illustrate different motions of the same body. Note, P is an arbitrary point of the body. Here we have considered the point P, that is just an arbitrary point, and O is the center of mass of the body, which is defined in the coming sections. Okay, O is the center of mass of the body. You can see that point O in each of that figure, isn't it? The trajectories of O are the translational trajectories, that is TR1 and TR2. Here you can see this is TR1, TR2. So these are translational trajectories. Okay. Okay, the positions O and P at three different instants of time are shown by O1, O2 and O3 and P1, P2 and P3. Okay, the positions at three different instants of time here they have shown in this figure, here also and here also. And since this is an example of translation, the velocity of that particle at every instant of time is same. At any instant, the velocities of any particle like O and P of the body are same in pure translation. In case of orientation, that is OP, you can see here, the angle OP makes with a fixed direction. You can see that angle OP here, it is shown in these figures. It is it is with the fixed direction. So we can say alpha 1 is equal to alpha 2 is equal to alpha 3 in case of translational motion. Whereas this figure B, it is a combination of both translational as well as rotational motion. Okay, alpha 1, alpha 2 and alpha 3 are not same in this case because the velocity, it differs in each case, isn't it? We know that, isn't it? Rotation will be about a fixed axis only unless scattered otherwise. Okay. The rolling motion of a cylinder down an inclined plane is combination of rotation about a fixed axis and translational. Thus, something else in case of rolling motion, which we referred in the earlier examples, what I told, there is something else in that case. Okay, when in the rolling motion case, that is when we consider that cylinder which is flowing from the inclined plane, isn't it? So, in case of that cylinder which is moving from an inclined plane, it was a combination of translational motion and rotational motion. So here these two are the examples, one for the pure translational motion and second one is a combination of translational as well as rotational motion. But these figures show the motion of the same body along identical translational trajectory, isn't it? We have considered a single translational trajectory. So now we recapitulate the most important observations of the present section, that is, the motion of a rigid body which is not pivoted or fixed in some way is either a pure translation or a combination of translation and rotation. The motion of a rigid body which is pivoted or fixed in some way is rotation. You got this right? The motion of a rigid body, if it is not fixed to a particular point or to a particular way, then we can say if it is not pivoted or fixed in some way, is either a pure translation or a combination of translation and rotation. So as we just that pure translation, we just saw the examples before, and even for this combination we just saw the example of that fan. The ceiling fan was where that axis was fixed in that case, and in this the one more fan, we just took an example here, an oscillating table fan. Here it is a combination of both translation and rotation. In some other cases where the motion of a rigid body is not pivoted or fixed to some particular point or way, then we call that as a rotation. Okay, the rotation may be about an axis that is fixed or moving, in as we saw in case of a oscillating table fan. Okay, so this is the simpler explanation of the translational and rotation, and even we saw the examples of rotation, how it works, isn't it? So next in the coming part, let us see what is center of mass. Okay,